Hello, my dear friends. This is your coach, Mr. Magno. We're back with part 2 of Module 6, Lesson 16. We're just going to read directions and do the work. Let's check this out. So, it says right here, use the coordinate plane, follow plane below to complete the following tasks. So, let's use this one here. We're going to complete these tasks. So, draw AB. That's easy. We can draw AB. There you go, AB. Now it says plot point C at 0, 8. So 0, x is 0, and 8, y is 8. So it's going to be right on the y-axis. And remember to label the axis. I keep forgetting that. That's y, and this is the x-axis. So the next step says draw AC. So I'm going to draw a segment from A to C. And guess what? You know that, right? This is a perpendicular line. Now, explain how you know the angle CAB, the angle C, let me label C right here, CAB is a right angle without measuring it. Well, one way is by looking, if you remember our prior lessons, if we make show the triangles that the angles make, these lines make, this triangle right here behind the triangle that is below the segment AB, there is that triangle, and this is a 90-degree angle. Okay, and do you see the exact same triangle but extending over here from point A to the y-axis, and you see the triangle right there. And again, this is 90 degrees. Okay. Now, when these two form those exact triangles, that means that the inside of that should be 90 degrees. How do we know that? Because if we were able to fold these papers in, and let me use a different color line. Let's see, do you see this? We can invert this right here, and that's going to be here. That's a number. This is the 2. And we'll show the line here. And if we can invert this one up here, and this 2 is going to be over here, there's going to be 2 here, and this is going to be this line right here is this one right here. This dot right here, it's right here. So you can see we can invert a mean that creates a 90-degree angles right here, and that's how we know this is a perpendicular line. Okay. So explain how you know that it's a right angle. Well, it is a right angle, right. Let me see if I spelled that correctly. Right, A-G-H-T, that is correct. Okay, it is a right angle because I can draw the triangle because I can draw the triangles and I'm talking about these triangles. I'm going to highlight them so you can see them. Okay. I can draw the triangles let's can say behind or behind segments. This is segment CA and segment. This is AB, and that's how you explain that one. Okay. Now let me zoom out, and we're going to look at the number 1E, and number 1E says right here, Sean drew the picture below to find a segment perpendicular to AB. So here is A and this is B. This is the segment. So the perpendicular one is this one right here. Explain why Sean is correct. Well, why Sean is correct because he inverted these triangles just like we did it on the previous problem. This that triangle that is behind the segments that we created. So we can say that he inverted these ones right here, these angles, and when he flipped them over in this one right here, they created a 90-degree angle. That's how we know. So that will be your explanation. It says, explain why Sean is correct. Sean, hello, my friend Sean. Sean is correct because if we flip the triangles behind, I'm going to write this differently. This is AB, so we're going to call it segment. This is called segment AB because the triangle behind AB, and what's this one right here? This one is going to be, so let's call this AB. We're going to call this C. Okay, so, and segment BC. Sean is correct because if we flip the triangles behind segments AB and BC, the new triangles inside, the new triangles, oh, let me show you, inside the right angle, and this is inside the right angle. Remember, this is inside, okay? This is inside the right angle equal, what do we say equal to? 90 degrees, okay? All right, so this is similar to what you're doing today for homework. Let's look at page number 2. Page number 2. Again, remember that the importance of reading instructions, okay? This one is, let's read the instructions. Use the coordinate plane, this one right here, below to complete the following tasks. Draw Q and T. Okay, that's simple. We can draw Q and T. So this is segment Q and T. Plot point R at 2, X is 2, so we're going to run to 2, and Y is 6.5. So we're going to go up, 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 up to 6.5. There it is. So 6.5 is between 6 and 7. So that is their point. So check. Draw QR. Okay, so let's label this. So this point is R. So we have to draw QR, the segment QR. There you have it. Okay. So next step, D. Explain how you know angle RQT is a right angle without measuring it. Okay, let's do the same exact thing we did with the previous one. Remember that behind these angles, there is a triangle. If you can see it right here, you place your like a ruler there, and you can see like behind this there is a triangle. Okay, and also if we can look at this one right here, we can imagine it or we can draw it like I'm doing it right now. So those are the triangles, right? And each of those triangles equals have a right angle, and it also has two acute angles, which means that these acute angles are less than 90 degrees. So when you add them up, equals 90. So 90 plus 90 equals 100. I mean 180. Acute angle, acute angle. So what happens if we flip these ones over? Well, if we flip them over, it's going to create another 180-degree angle. And that's how we know. So let's explain that one. Okay, so it is a right angle because um, flipping that should be up. Let me see. Flipping is with two pieces. Yes, I think it's flipping um, the imaginary triangles inside the right angle, I'm going to write this, the right, I'm going to use a symbol so you have space, a right angle, okay. It is a right angle because flipping the imaginary triangles inside the right angle, flipping the imaginary triangles inside the right angle, create a 90-degree angle. Create a 90-degree angle. Okay, so that's it. And this is the right. If we flip this one's inside, like I showed you on the other one, here is the one that it's outside, and here is the one. This is the line for this side, and this is the new right angle. Okay, next, compare the coordinates of points Q and T. Okay, so Q and T. So Q is, okay, so let's do Q. There's the coordinates. Q is 3 1/2. 3 and 1, let's see, 3 and 1/2, and Y is 4. So we have to write them down before to be able to compare them. And T. So T is, we're going to run to X. That's going to be 6, 6 and 5 and 1/2. So 6 and 5 and 1/2. So notice that it says what is the difference of the X coordinates. So let's say X coordinates, the difference between this one, 6, remember it says a difference, that means a subtraction. So the difference between 6 and 3.5 is 2 and 1/2. Okay, and what is the difference between the Y coordinates? Well, the difference is 1 and, okay, Y, the difference is, and I'm just going to write it like this, equals, let's say we say 1 and 1/2. So that's what they're talking about. That's the difference. Okay, on the next one, compare the coordinates of points Q and R. Okay, so let's get Q. Q, we already wrote it down. Let me show you here. So Q is already there. We're going to copy it. It's 3 and 1/2 and 4. And we said R. The point R is up here, so we already have R. R is 2 and 6 and 1/2. Okay, so R is 2 and 6 and 1/2. Okay, now it says compare the points. What is the difference of the X coordinates? Again, we're going to find out the difference between them. Between the X coordinates, the difference is X is right here, so the difference is 1 and 1/2. And what is the difference between the X coordinates? Difference between these two is 2 and 1/2. Okay, notice how they shift. They changed, they flip. X became 2 and 1/2, Y over here. So this is X, and it became Y over here on this one. And this is Y, and Y became X over here. Okay, excellent. So just analyzing, that's what helps a lot when you're doing these kinds of problems. Okay, now the next one. What is the relationship of the differences you found in parts E and F to the triangles of which these two segments are apart? So the difference in X coordinates for Q and T was the same as the difference in Y. Oh, that's exactly what we, okay, so we're just going to explain what I just pointed out to you. And what I pointed out to you is this. What is the relationship with the difference you found in parts E and F to the triangles of which these segments are apart? So we can say that the difference, let's see, so the difference in X coordinates, the difference in X coordinates, okay, of Q and T, of Q and T. So here's Q and T. The difference of Q and T was the same as the difference, was the same as the difference in y coordinates of Q and R. So this is what they're saying, that the X became Y for Q and R, and Y became X for Q and R. So I'm not going to write the rest of it. So the rest of it will be the difference, well, you will say the difference in Y coordinates of Q and T of, it's a Q and T, let's see, are we comparing E and F? Okay, of Q and T was, I'm going to write the same thing, was the same as the difference in, okay, the difference in X coordinates of Q and R, of Q and R. Okay, so this is what it takes on this one. We've got to analyze lines and points and then come up with your conclusions. The last one is going to be somewhat simpler, because what happens is going to happen the same thing as above. So for example, on this one is we have a segment E and F, and then we want the coordinates of a pair of points G and H, such as where EH, which is this segment right here, is perpendicular to GH. And this is what would happen. These numbers will change. So for example, the Y on this one is going to become the X on G. So that's going to become the X of G. And the X on this one is going to become the Y on G. And now we have the Y of this point becomes the X of H. And the X on E becomes the Y of this. So see how they flip? That's exactly what we've been doing. Okay, my friends, watch the video, pay attention, ask questions, and just be proud of what you do. Your coach, Mr. Magno, is signing out.